All right, class. Well, today we learned about dividing polynomials, and so I made this video for you in case you were either out or would like to review this PowerPoint um, at a later time. So the first thing we talked about was standard forms of polynomial functions. So if we look at a linear function, the standard form is y equals ax plus b. If you notice, this degree 1 polynomial has two terms. For a quadratic, the standard form is y equals ax squared plus bx plus c. And you can see this degree 2 polynomial has three terms. For a cubic, here's our cubic function, and you can see that this degree 3 polynomial has four terms. And finally, the quartic function, and you can see it has five terms. So if we were trying to look at the relationship between the degree of the polynomial and how many terms we have, you can see that for whatever degree it is, we have exactly one more term. So for instance, how many terms will be included in the standard form of a function with degree 6? So we know that there will be 7 terms. For a degree 20 polynomial, there will be 21 terms. This is important for the next part of the lesson. If we were to multiply a linear factor by a linear factor, we should expect to get a quadratic factor. This is because we have a degree 1 times a degree 1, which if we add them together, we get a degree 2, which is quadratic. So a linear times a quadratic is a cubic because we have a degree 1 times a degree 2, which equals a degree 3. For a quadratic times a quadratic, we have a degree 2 times a degree 2, which is a degree 4, or a quartic. For a quadratic times a quartic, we have a 6th degree polynomial. We can do the same thing if we wanted to figure out what we needed to multiply by. So in this case, we want to know what can we multiply a linear factor by to get a cubic. Well, we know that has to be quadratic because a linear times a quadratic is a cubic. Same thing for number 2. If we have a linear factor, we know we can multiply that by another linear factor in order to get a quadratic. If we start with a quadratic and we want a degree 5 polynomial, we need to multiply that quadratic by a cubic. And number 4, if we have a cubic and we want a degree 6 polynomial, we have to multiply it by a cubic. Again, this is very important for the next part of the lesson. So this is just review on how to multiply two polynomials using the box method. So we want to answer these questions. So for A, what type of polynomial will we expect to get if we multiply the polynomials together? Well, for A, we have a linear times a linear. So we should expect to get a quadratic. The number of terms we should expect to have is 3, because quadratics have 3 terms. For B, we want to know what type of polynomial we will get if we multiply a quadratic by a linear. The polynomial we should get is a cubic. And we know a cubic has 4 terms. You can see those answers on the next 2 slides. Now we want to use the box method to multiply the polynomials. Since I have a binomial, which has 2 terms, times a binomial, I know it's going to be a 2 by 2 box. And you can see over here that I put the first factor to the left and the second factor on top. It doesn't matter which order you put them in, as long as you have this 2 by 2 box. Within each box, we just have to multiply 2x times x to get 2x squared, and so on. Then we can combine everything to get that 2x plus 5 times x minus 3 is equal to 2x squared minus x minus 15. We can do something similar with b. The difference is, since we have a quadratic times a linear, we need a 3 by 2 box. And in this case, you can see I did a 2 by 3. Again, it doesn't matter which of the factors go on the left and which go on the top. And we would do something similar. You should see that the diagonals always have the same values, and that again is important for us to know as we move forward. So now what we want to do is we want to use the information to actually find the missing polynomial. So instead of having the two polynomials being multiplied, we want to find that missing polynomial so that we get a quadratic. Well, we know it's got to be linear because a linear times a linear gives us a quadratic. Since it's a linear that we're looking for, we should expect two terms, which means our box should be a 2 by 2 box. So I'm going to start off with a box. We know the left side, 3x plus 2, but we don't know the top. What we can start with, though, is 3x squared, because we know it's got to end up equaling 3x squared on the right. So since I know 3x squared is in this box, and I know 3x is to the left, that means the top has to be x, because 3x times x gives us 3x squared. Well, once we've figured that out, we can just multiply down and multiply x by 2 to get 2x. The next part is the slightly trickier part. Remember, the diagonal should be the same. So if we know the bottom left is 2x, we know the top right has to be some x. And we know when we add them together, we should get this negative x. So we want to know what value, when added or subtracted to 2x, gives us negative x. And we know that that has to be negative 3x. So that is what will go in the box. Finally, we can figure out what goes on the top right, because 3x times what gives us negative 3x? Well, that's negative 1. Finally, we can finish our last box by doing 2 times negative 1, which will be negative 2. This means our missing polynomial was x minus 1. In other words, 3x plus 2 times x minus 1 equals 3x squared minus x minus 2. Now we want to do something similar with missing polynomial 2. So again, we have a linear factor, and we want to know what we need to multiply by to give us a quadratic. So we know it's got to be linear, and we know a linear factor has two terms. So let's go ahead and set up our box the same way we did with the first one. The polynomial we know is on the left, and the x squared term is in that box. So we know 3x times what gives us 9x squared? Well, that's 3x. As soon as we know this, we can automatically multiply down to find this value because it's just negative 1 times 3x. Finally, we want these two terms, because we know they're going to both be x, we want them to add to give us 0 because we don't have an x term here. So the term that's going to cancel negative 3x out is a positive 3x. Those will cancel to be 0, which is what we want. Next, 3x times what gives us 3x? Well, that's 1. So 1's going to come up here. Finally, 1 times negative 1 gives us negative 1. So our missing polynomial is 3x plus 1. So now let's move on to a cubic. So we want to know what we have to multiply that linear factor by to get a cubic. Well, we know it has to be quadratic, and quadratics have 3 terms. So our box should be a 2 by 3 box. So I'm going to set up a 2 by 3 box the same way as before, with my linear to the left and my 6x cubed inside. I now want to know 2x times what gives me 6x cubed? Well, I know that is 3x squared. Once I know 3x squared, I can then multiply down to get 3x squared times 3, which gives us 9x squared. Now I'm going to use the first diagonal, this diagonal right here. We know they're both going to be x squareds, and what I want my x squareds to be equal to is 19x squared. Right now I have 9x squared. So this has to be 10x squared, such that when I add them, we get 19x squared. Now we can figure out this term, because 2x times what gives us 10x squared? Well, that's 5x. Now we can multiply back down to get 15x. We have this new diagonal. We want our x's, we know they're both going to be x's. We want these x's to add to give us 13x. Right now we have 15x, so to get 13x, we have to subtract 2x from it. That means that we know that 2x times what gives us negative 2x? That's a negative 1, so that's our value up here. Then always multiply back down just to finish your box. And so we get that our missing polynomial is 3x squared plus 5x minus 1. Here's a new slide. How is this alike and or different from the previous examples? So let me go back again. So notice here I'm asking you to find the missing polynomial. Here I'm asking you to divide, so that's one difference. But the similarity is that I'm really asking you to divide on this other slide. Because if I want to find what number times 2x plus 3 gives me that, I can just divide both sides by 2x plus 3. So essentially what you have been doing is dividing these polynomials. So when I ask it in this way versus this way, it's the exact same thing. So you can just use the box in the same way that we did in the last 3 examples. So first of all, we want to know what do we need to multiply x squared by, or a quadratic, to get a quartic? Well, we know that it's got to be another quadratic. So our box is going to be a 3 by 3 box because we have a quadratic times a quadratic. So I'm going to set up with what I know, the 2x squared plus 3x minus 1 along the left, with the negative 6x to the fourth in the first box. Now I can do everything exactly the same. We want to know, what do we need to multiply 2x squared by to get negative 6x to the fourth? And that happens to be negative 3x squared. As soon as we know that value, we can go ahead and multiply down to get the rest of the column. Now we can start with our first diagonal. Here's our x cubes. We want our x cubes to equal 1x cubed. Right now we have minus 9x cubed, so in order for this to add to be 1, we need to add a 10x cubed. Now we can figure out this value up here, because 2x squared times what gives us 10x cubed? And that is 5x. Finally, we can multiply back down to get that whole column. Our next step is we have x squareds along this diagonal. We want it to equal 30x squared. Right now we have a total of 18x squared, so that means this missing one has to be 12x squared so that it adds to be 30x squared. So that allows us to find this last term. So 2x squared times what gives us 12x squared? And that's 6. So our last step is to multiply down and get the rest of our box. And we should always double check. We haven't checked the x's yet, but if we add them, we get 13x. And our last box gives us negative 6. So we should always check these to make sure that they are what they're supposed to be. If not, and we'll find out on Monday what happens, and what we have to